Dear students, today we are going to discuss about indicators. As you know, acid are sour in taste and base are bitter in taste. So we can easily identify by its taste. But acid and base are corrosive in nature. If we try to taste it, it may hurt us. It may burn our mouths, tongue, and internal organs. So we can't taste acid or base for identifying. Never try to taste acid or base for testing them. So we want to test acid and base. We use indicators. Indicators are some substances that is used to test whether the substance is acidic or basic. Indicators change its color or smell in the presence of base or acid. One example is litmus solution. There are many types of indicators we can use in our daily lives, and we can easily made by using natural colors available from our surroundings. We can discuss some of them. First one is olfactory indicators. Olfactory indicators are indicators which changes its smell in acidic or basic media. If we add an olfactory indicator to acid, it produces some smells. If we add the same in base, it may produce another smell. We can identify it by using its smell. Another one is natural indicators. Natural indicators are indicators obtained from our surroundings in nature directly. Turmeric is a natural indicator. Litmus is another natural indicator. We can easily make litmus from lichens. Lichens is a fungi obtained in pond water or near stones near the ponds. Or we can make litmus by using China rose petals. China rose is a flower easily available in our surroundings, and by taking the petals of China rose and take the petals of China rose and rub in a white paper, its color turns blue. It's a blue litmus. Another one is synthetic indicators, methyl, orange, phenolphthalein, etc. etc. All indicators have a specific color change in acidic and basic media. We can easily identify whether the substance is acid or base by using these indicators. Red litmus. Its natural color is red. In the acidic media, it remains red. In basic media, it turns blue. That means when we dip a red litmus to acid, its color remains red. It will not change. But if we dip a red litmus into base, its color turns to blue. It changes to blue. Another indicator is blue litmus. Its natural color is blue. If we dip a blue litmus in acid, it turns to red. If we dip the same blue litmus into base, it remains blue itself. Did not show any change. Phenolphthalein. Its natural color is colorless. In acid, it remains colorless. In base, it changes to pink. Methyl orange. Its natural color is reddish orange. In acidic media, it turns red. In basic media, it turns yellow. That means the reddish orange, methyl orange, if we add into acid, the color of solution turns to red. If we add in base, color of solution changes to yellow. This is the example. Litmus test example. We dip litmus paper, red litmus, in acid, and turns blue when we dip it in basic solution. Now we are going to discuss about the chemical properties of acids. In your text, it is detail you can read. In simply, I will explain what happened when when acid react with many other substances like metals, metal carbonate, metal hydrogen carbonate, metallic oxides, etc., etc. First, we are going to discuss about the reactions of acid with metals. You can see the equation: acid plus metal gives salt plus hydrogen gas. That means when we add acid to a metal, the metal will change to salt and it produce hydrogen gas. For example, 2HCl. HCl is hydrochloric acid, Zn is metal. 2HCl plus Zn gives ZnCl2, zinc chloride, it's a salt and hydrogen gas. You already studied in your previous class about the chemical reactions and equations. It's a 2HCl plus Zn gives ZnCl2 plus H2 is a chemical equation. It represents the chemical reaction of metals with acids. In our daily life, we didn't use pickles in metal pots. If we keep pickle or anything contain acid in metal container, it may damage easily. The pot will damage and our ingredient, food item also ruined. That means the acid in that pickle or anything we take have a sour taste, react with the metal and produce hydrogen gas and metal salt. Next, metal with carbonate. Acid react with metal carbonate. Acid plus metal carbonate gives salt plus carbon dioxide plus water. For example, 2HCl plus Na2CO3. Na2CO3 is metal carbonate. Metal carbonate is formed when a metal react with a carbonate. Carbonate means carbon plus carbon react with oxygen to produce carbonate. Gives 2NaCl plus CO2 plus H2O. 2HCl plus Na2CO3 plus gives 2NaCl plus CO2 plus H2O. 2HCl is an acid, Na2CO3 is metal carbonate, NaCl is metal salt. NaCl is a common salt we used in our daily life, sodium chloride plus carbon dioxide plus water. Acid react with metal hydrogen carbonate. Acid plus metal hydrogen carbonate also gives salt plus carbon dioxide plus water. HCl plus NaCO3 gives NaCl plus CO2 plus H2O. Both the metal carbonate and metal hydrogen carbonate show same chemical reactions with acid. Acid react with metallic oxides. Acid plus metal oxide gives salt plus water. 2HCl plus CaO, calcium oxide, is a metal oxide, gives calcium chloride, is say salt plus H2O, water. In addition to the above discussed properties, acids shows its taste as sour in taste. Its own property of acid. Commonly using acids are lemon juice, vinegar, tamarind, sour milk, etc., etc. It contains different types of acids. Sour milk contains lactic acid, tamarind contains tartaric acid, vinegar contains ethanoic acid, commonly called it is acetic acid. Lemon juice contains citric acid and ascorbic acid. It contains vitamin C. Another property is action on indicators. We already discussed about that. Litmus turns to red, and phenolphthalein turns to colorless. Methyl orange turns to red. Another property is conduction of electricity and dissociation of acids. Acids conduct electricity. If pure water didn't conduct electricity, but if you add some acid to it, it conducts electricity, because we already discussed acid produce hydronium ions. Ions conduct electricity easily. And another term is dissociation of acid. Dissociation means another property is conduction of electricity and dissociation of acid. Acid conduct electricity because it contains hydronium ions. When acid passes through electricity passes through acid, it dissociates. It means it separates H plus H2O. When acids are dissolved in water, they produce ions which help in conducting the electricity. This process is known as dissociation. That means the property of acid to dissolve in water. Some acids completely dissolve in water. This type of acids are known as strong acids. The acids which completely dissociate in water are called strong acids. Some acids which dissociate partially in water, this is called weak acids. Example for strong acid is HCl, hydrochloric acid, hydrobromic acid, hydroiodic acid, chloric acid, nitric acid, etc. Example for weak acid is ethanoic acid, benzoic acid, hydrofluoric acid, hydrocinic acid, etc. Another property of acid is acids are corrosive in nature. It may hurt us or any other substances if we pour acid into it. All these are the main properties of acid. Tomorrow we can discuss about the properties of base.